Hello guys, thanks for joining me once again. I'm out with the XP Deus II and this video is going to be all about tests and experiments because I want to show you the advantages of fast multi-frequency. Our first demonstration refers to subtraction, ground subtraction. So let's get out in the field and demonstrate the halo effect. One common issue with any single frequency metal detector is the halo effect, and you've probably experienced it yourself. You get a soft, faint signal, it sounds like a deep target, you dig down and there's simply nothing there. And this is more noticeable in the damp, wet ground. It's something to do with the water table. I've got the Deus I here in Deus Fast, single frequency. I'm just going to let you listen to what I believe is a halo effect. Here we go. Sounds pretty good, doesn't it? I'm getting no meter readings, but a soft, consistent sound. Now, the beauty of a fast multi-frequency machine is these halo effects no longer exist. They're eliminated at source. Let's try the same target with the Deus II. We're in the general program now, no adjustments made. The same target. Absolutely nothing there. So fast multi-frequency eliminates these halo effects, therefore you can spend more time digging the real targets. One of the main advantages of simultaneous multi-frequency is frequency addition. You can add high and low frequencies to the same program in order to give you a wider range of targets, high and low conductors. Now I'm going to show you a little experiment here with some highly conductive coins. We're going to run the Deus I over them and select different frequencies and just let you hear what they sound like. These coins will be together in a line so they're actually touching, and it simulates a coin spill which we may be walking over every time we go detecting. And then I'm going to try the same experiment with the Deus II in general mode with no adjustments, and I'm just going to let you hear what it sounds like. Deus I, the standard Deus Fast program with the X35 coil using 17 kilohertz. Let's see what it sounds like over that line of coins. Absolutely nothing. I'm going to turn the frequency up now to 25 kilohertz. Nothing. So let's go down. 7.7 kilohertz. So 7 kilohertz gets it really well. Let's just go up between the two, 11 kilohertz. 11 kilohertz starts to lose it, so that's indicating possibly iron. So we'd probably walk over that. Let's put this down for a moment and try the Deus II. Deus II, the standard general program, no adjustments made. No problem whatsoever, and this is the advantages of simultaneous multi-frequency. But what about the low conductive targets, the very small targets? Let's see how it deals with those. High frequencies with low conductive targets, and just to give the Deus I a head start, I've put the HF coil on. I'm going to go over this target here in front of me, which is a tiny little gold nugget. It registers about 34, 35 on the target ID. I'm going to go over it in 14 kilohertz Deus Fast program. Let's hear what it sounds like. As you can hear there, it's getting it, but it's just on the fringe of detection. Let's try the same target using 30 kilohertz. .30 kilohertz. So that's quite obvious. The higher frequencies are much better on the low conductive targets. Let's try this same target with the Deus II using the standard general program. Deus II general program. Absolutely perfect. So that just proves the advantages of using simultaneous multi-frequencies. You're getting those low conductive targets and the masses of high conductive targets all under one program. Let's have a little talk about subtraction, in particular soil subtraction. The Deus simultaneous multi-frequency can subtract unwanted ground. For example, conductive ground such as salt water, or magnetic ground such as mineralised soils. In front of me here I've got a tub of highly mineralised soil. It's so magnetic you can't even use a pinpoint probe on it. Let me demonstrate. As you can see, it's really magnetic. Now in the middle there I've got a small silver hammered coin buried about 2 inches. First of all, I'm going to try the Deus I using the high frequency coil, run through the frequencies, let you listen to it, and then I'm going to go over the same target with the Deus II in general mode, no adjustments made. Here we go, nice and quick, Deus fast, 14 kilohertz. Let's take it up to 30 kilohertz. It's giving the iron click, isn't it? And to the top, 54 kilohertz. Slightly coming in there, isn't it, with a 54 kilohertz? But it's still, I don't know. Right, let's go on to the Deus II and give it a try. No adjustments needed. Here we go. Perfect signal. There's one feature which I think is unique to the Deus II, and that is a very fine notch adjustment. So you can notch out unwanted targets without the fear of losing something good, which falls within a similar target ID range. I'm just going to show you a little experiment now with coke. I'm still using the general program, which doesn't eliminate coke, it eliminates conductive ground and the halos, what we talked about earlier. So what I'm going to do first of all, I'm going to go over the coke and get a target ID. That's coming up at exactly 25. So what I'm going to do here is notch out the window from 23 to 25. And that's easily done by going into discrimination, expert, scroll down until you see the notch window, hit the expert, and now we need to set our notch adjustments. I like to do threshold 2 first of all, so that's going to be 25. And then threshold 1 is your lower number. I'm going to go up to 23. So there's my notch window set, 23 to 25. Let's just check and see if it's eliminated the coke. Perfect, absolutely nothing. And next to the coke I've got a very small hammered coin. Let's see what that sounds like. Because here in the UK, if we eliminate coke, we stand a good chance of eliminating those small hammered coins. So this experiment is just demonstrating we can remove coke without losing the coin. What happens if I put the coke on top of the coin? This will be an interesting one. Here we go, coke on top of the coin. Absolutely perfect. That fine notch is a fantastic feature, and I think we're going to be using that a lot in the future. Well, that's it from me, guys. I hope that's given you a little bit more information about the advantages of fast multi-frequency. This field out here is looking very tempting. I've got to swing this coil, so until next time, take care and I'll see you soon.